the need to have forward error correction, to have reliable UDP.
18 years ago within Global Mix, within multicast.
That's right, because you had your own webcast production company.
CDN, really. It was
CDN,
but we were interested in scaling multicast in the public consumer networks. Crazy project, different story. It's in the book.
Okay.
But basically,
always comes back to the book.
It always comes back to the book. But basically, when you're pushing a packet out with a connectionless environment, which is UDP.
Right.
And don't forget, TCP is UDP with back channel. TCP is like a specific use case of UDP.
Right. Yeah.
It's just a very, very good one and very established. The problem is it's designed to be a good net citizen.
Right, but it
shares the session over the network, and if two people doing separate things are trying to use the same link, it will be fair to both.
Right.
So what's happened with a lot of the more recent Matamas, Asperas, those players who've come into the space, is they're saying, well, if this is your IP network and you don't want to be a good net citizen to other people, then force the UDP down, saturate the links, and don't have a TCP to back your network throughput off.
I think of TCP in cartoon terms with Chip and Dale, the two chipmunks, after you, no after you, no after you.
Yeah.
Where UDP is sort of Hulk coming in and just blasting.
Just drives through regardless. Yeah. But then the problem is when you start losing packets, you need to have some intelligence to actually manage that. So and you can layer in forward error corrections. So where we've gone, interesting, I mean this might be relevant, where we went, we built our own link aggregation and contribution stack. Okay. I suppose something akin to what SRT's been about and so on, but also it's a little bit, our outcome is a little bit more like maybe Quick as an evolution of Speedy has been. We try to turn TCP into something that looks like UDP rather than try to turn all the TCP connections into UDP. So what we're really interested in is very, very, very small fragments of data over many paths.
Doesn't that increase the chattiness though, or are you decreasing the
But
chattiness?
it also allows the back-off processes to happen in lots of different managed ways, and you don't need to implement a reliability protocol over the top. It is a reliability protocol.
And you don't need a standalone
and you don't need firewall managed,
you
don't need, it's just works. So for particularly the NASDAQ guys, they use that extensively in the field encoders we developed for them. Just because it's quick and easy and they don't have to think about firewalls. It also brings link aggregation and cellular bonding as a byproduct.
So it does NAT, traversal, that kind of thing?
It's
because
TCP.
It's TCP, you're right. Okay, fair point. All right, where can people get the book?
Go to Amazon, check it on Amazon. That's the fastest way to get the copies delivered. You can go to the wiley.com site. Okay. And if you message me directly, I can give you a little, during November, I can give you a little 20% off.
Nice, Streaming Media 2017 discount.
That's it, yeah.
All right, awesome. Thank you, Dom, as always, and I like the hat.
Yeah, it's for my writing road only. There, back to ideas.
Welcome back to Streaming Media West 2017. I'm here with Dom Robinson from Ideas. Dom, tell us quickly what's Ideas.
So Ideas is a software company. We've been around for about 10 years now, 8 years. Very focused on microservice architected delivery of video workflows. Okay. So we about 8 years ago we took what was then Reuters and is now NASDAQ's video workflow into the cloud, which was quite a big radical move for them. Big OPEX savings, and we now deliver 40,000 live events a year for those guys. It's all fully automated and all cloud-based.
Kind of the fair disclosure types of
fair
events?
Disclosure, corporate announcements.
Okay.
So it's a very cyclical quarterly business. Sure. As a case study in its own right.
Oh, I'm sure. Yeah, because everybody wants to cram it into about 2 weeks of earnings.
That's it. And then we have 3 months where there was massive underutilization. So they came to us and we suggested virtualizing it. This was before anyone else was doing it at that scale. And it left us with a really interesting stack. We use an unusual telecoms language, which will be familiar to the WhatsApp engineering team or the Twitter engineering team, but most other people haven't heard of Erlang.
Right. Yep.
And it's really designed for developing carrier class video workflows.
A lot of high transaction, yeah.
And it's self-healing, which is really fundamental. We don't have to spend a lot of time engineering for the failure cases. So that's where we, as a very small company, get a very strong competitive edge over much bigger companies.
Very interesting. And of course, you're a streaming media contributing editor.
I'll put my writer's hat on.
Yeah, exactly. And you and I and Eric have started SMAF, Streaming Media Advanced Forum, which we're not really allowed to talk about here, but people can come to smadvancedforum.com and catch up on what we did walking around the show floor today.
That's it, yeah, informal.
And you have a book, and I'm going to hold the book up in my best Vanna White impersonation, and I'll put it here so that it's part of the close-up. But this is Content Delivery Networks, Fundamentals, Design, and Evolution. You've been an editor on other books in the past. I think I contributed a chapter or two, right, exactly, the one that Mukadim and you did. Yeah. This is your own book.
Yeah.
So tell me just briefly about the book.
So as an outcome of doing that book for Wiley, the one with Mukadim and Ramesh, I noticed that the academic books were always about current best practice.
Okay.
There was very much a competition between people to sort of say this is the best way you can possibly do this.
Which makes sense from an educational
absolutely valid, but there was a sense that people coming into the industry, moving into the sector for the first time or moving across from a different role of responsibility, really wanted to understand streaming content delivery networks. They didn't have context and they didn't have a picture of the cycles in the industry and so on. Okay. So the sections I'd written for that book were much more of a short, concise history of the sector. Right. And basically what I've done is I've elaborated on that and expounded that to this book, which is much more, to an extent, my voyage into the industry over 20 years. Okay. But it goes into technical detail about things like I've got a real belief in service velocity as the fundamental driver between most technical decisions and how you should be architecting content delivery networks and streaming workflows and probably other aspects of your business workflow.
So let's do a slight tangent off that. We'll come back to the book at the very end, but cellular bonding, cellular muxing, this was something you got into early on, and now I was just on a panel with Chris Knowlton where we're talking about that as sort of a nice redundancy to house Ethernet. Where do you see that some of these technologies are going in terms of the ability to deliver live from almost anywhere? Because it used to be if you went remotely, if you went out into the field, quote unquote, you had to roll a satellite truck. Now most people are saying, oh yeah, we can do this with a couple cell muxes.
Yeah, so I mean, if you're very puritanical about it, the capability's been in the Linux kernel for 12 years. Okay. Maybe even a little bit longer. Link Aggregation Control Protocol, LACP, was doing channel bonding a good decade ago.
And it makes sense because those of us like me who came out of video conferencing, we would do
ISDN
bonding of B channels and then have the back channel for control.
And then when I started reviewing, so no one was really focused on that space 6 or 8 years ago. So when Eric was asking me to write a little bit more about it, I realized that it wasn't good enough just to talk about link aggregation or channel bonded link aggregation. So I started creating these tiers. Okay. So you've got link aggregation, which you can just do with a standalone modem. Sure. You can put it's a router. You've got 5 different IP connections, and if you're doing little bursts of data like web data, an office can get a sense that they're all aggregated because between all the office users there's always availability. Sure. But you can't treat it all as a single pipe if you're trying to stream over it. Right. What you need to do that is you need something that will multiplex and demultiplex the signal at both ends. So then you get a channel bonding link aggregator, which actually bonds the different channels together with a counterpart system, the remote end, which creates a bit of a buffer basically, and will take if you've got 3 1 megabit connections, it will turn it into as far as everything else is concerned, a 3 megabit pipe.
And this is similar in some ways to the home load balancers you can get if you have a DSL and a cable
And in
modem.
fact, some of those vendors are dominant vendors in there. So Vislink and Mushroom Networks, those guys were all about having multiple redundant paths between offices and actually being able to use them all as a single pipe to do high bandwidth file transfer, that sort of thing.
Right, sure.
And then you've got then there's another generation on top of that, which is what you start seeing in backpacks and increasingly on camera top systems.
Teradek, Live View, etc.
Exactly, and those guys, what they've done is they've actually got the specific application of the encoding is able to apply back pressure, if you like, in the buffer, with the link aggregator, so that if you can't you can understand whether you want to drop the bit rate of your video because your availability's gone wrong. So if your 3 megabit drops to 1 megabit, you can actually signal to the encoder, drop from a 3 megabit encoding down to a 1 megabit encoding. So I call those cell muxes, cellular multiplexers, but
and that leads naturally into the very last topic I want to talk to you about, which is reliable UDP, because one of the things we were talking about in this panel was you got the cell bonding, you got the muxing, as you say, but ultimately if the network's not stable and if you can't aggregate together well from all these different service providers, the need to have forward error correction, to have reliable UDP, where do you see that going?
So reliable UDP, I certainly was using it 18 years ago within Global Mix, within multicast.
That's right, because you had your own webcast production company.
CDN really, it was
CDN,
but we were interested in scaling multicast in the public consumer networks. Crazy project, different story. It's in the book.
Okay.
But basically,
always comes back to the book.
It always comes back to the book. But basically, when you're pushing a packet out with a connectionless environment, which is UDP.
Right.
But don't forget, TCP is UDP with back channel. TCP is like a specific use case of UDP.
Right. Yeah.
It's just a very, very good one and very established. The problem is it's designed to be a good net citizen.
Right, but not
it shares the session over the network, and if two people doing separate things are trying to use the same link, it will be fair to both.
Right.
So what's happened with a lot of the more recent Matamas, Asperas, those players who've come into the space, is they're saying, well, if this is your IP network and you don't want to be a good net citizen to other people, then force the UDP down, saturate the links, and don't have a TCP to back your network throughput off.
I think of TCP in cartoon terms with Chip and Dale, the two chipmunks, after you, no after you, no after you.
Yeah.
Where UDP is sort of Hulk coming in and just blasting.
Just drives
through
regardless. Yeah. But then the problem is when you start losing packets, you need to have some intelligence to actually manage that. So and you can layer in forward error corrections. So where we've gone, interesting, I mean this might be relevant,